talk to you, Bobby.
About a fan? Why would I have a fan?
I know. So you said you would probably have one.
It's the old smoke and mirror deal.
Yeah. Morning. Hey, you're here. Great. Welcome. It's summer again in here. I was excited about fall. This is planned. I'm really excited. I know, it's so good. I was getting dressed this morning and I didn't front of the window. Yes! Oh man, I left my printouts. Dang. I'll bring them tomorrow. Yeah, I got really excited. Our test is on Tuesday, right? I'm working on it. I'm trying to get Bobby to bring us a plan of some sort.
Cool outside.
Yeah.
Cooler if we just did class
Do
outside.
the windows open? No, but come on, Bobby. Yeah. So math club's gonna meet on Friday at 10. Free donuts.
Yeah,
Tell them you got stuff to do at 10 o'clock.
Take
Credit?
What? Yeah.
Oh.
Did you not get the phone?
You got stuff to do at 10 o'clock. Tell 'em that.
Are you still doing like after this period stuff?
Yes, but I have class at 10:15, so I'll be here until however long, but I have to go to class at 10:15. 0.4 was too rough?
Did we even do logarithms in pre-calculus?
Yes.
Was that pre-calculus 1?
No. Wait, was it? Yeah, it was the very end of Math 171.
There you go.
And it was on your final exam in 171.
I'm gonna need a refresher. I was saying outside to Josh, I'm happy I decided to overdress a little because
Well, the air conditioner is broken, so I'm waiting on Bobby to bring us a fan of some
The
sort.
whole building air conditions. That's great.
was it that hot downstairs?
No.
But they don't
Hot
have
air
air on
rod
the
is
stairs.
It is hot.
The equipment in this room does like
Like classes. Can't have
it's
a
really
bunch of
hot right here. It's like standing in a
My sugar gets low when I get hot, so
Class cancel.
gotta go. Good thing I can take this off.
Did you email Doe?
Yeah. He said he signed it and returned it, so I don't know what that means, but.
Do you know when she's going to do this?
Like today. We're gonna go sit in Khaled's office. But it's on secret.
Sounds so fun. Her way week.
We're not. Mason will cry
I believe
every
it.
single
I
day.
believe it. I believe it.
I know that. It's depressing.
I believe it. What? It's hot here.
It feels wonderful in here.
I love it. I mean, not when you're wearing pants and whatever you want to call that.
Yeah, you're an idiot.
It's cold outside. The AC is broken. Like, actually.
Okay. I mean, it's like 40 degrees in the GAN, so.
Yeah, you know what's wrong. Hey,
We're like 20.
we're gonna do our chemistry. We're gonna get it done.
Okay.
We're
There's
gonna
not
get
that
it done.
much.
Oh, shit.
It's right outside my driveway.
I told her to send her.
Wasn't even moving.
You must live near Farmington.
Yep.
There was so much extra traffic this morning, but it was so irrelevant for me because I live nowhere close to Farmington, and it wasn't like school people. It was just like extra traffic, and like I could tell because it was just like men and trucks and stuff. And I didn't leave at a different time than I normally do. I was just like, what the heck? I sat at the end of my road for like 4 minutes trying to pull out. I was like, where are all these people coming from? Maybe they were like
Taking their kids to
yeah,
school.
maybe they had small children.
Maybe they were avoiding the.
Because I live directly in between Ellis, Shady Grove, and Hornets.
They're probably avoiding the other traffic.
And then a bus blew their horn at me or someone behind me. I don't know who. See me. Well, they were on the other side and they were stopped in the traffic. Their sign was not out, so I just whizzed by them.
Jeez, Sammy.
Me too, Sam.
Yeah,
You know you can like lose your license for that.
They weren't stopped. Like they were just in the traffic. But they started blowing their horn. I was like, that better not be at me.
I did nothing wrong.
But then I went like 15 over to get here in time.
Just like, let's go fast. You're not. I have a class at 8.
And then the traffic is backed up 158 from Farmington. I feel bad for the people who are like trying to get to North Davie, because they start schooling like 8:45, 8:55-ish.
At the end of the day, You need to try again.
But I'm sure they're doing something about that. They have to figure out the traffic, and I'm sure there's some other there.
Well, there's nothing we can really do about it. They can like, don't come to school.
Yeah, but they changed school time.
It's probably just because it was the first day. It'll be fine later.
Okay.
When people start being late and not on time.
You know how parents always take their kids on the first day of school?
No, I've not had any problems.
Oh, this
I just dialed up and they just drag us in automatically.
I'm just so happy about point
Here,
four.
just in case.
Or point four, because I actually did. Very proud of myself.
Yeah, it's
Oh, the thing you did do? You didn't know?
No, I did not have to do it.
Zero.
And here's my handy
That
dandy.
was, no, that was pre-algebra stuff, or whatever the first calculus is called. The second trig, right?
Yes.
Yes, I don't know. I just know that I know how to do it.
I
And
knew how to do some of it, but I really didn't care.
You did?
I shot it on the board. Those lines I actually hard
Really?
to until we could make it to just the barrel. Yeah, just the front barrel.
Oh, it did say number one. Oh, I just
Miss
skipped
Klinger,
right
they
by it.
fired my gym teacher, I'm pretty sure.
Good.
Because they canceled the whole class for the semester.
Wait, does it that means he was fired?
Well, it said that he would not be worked now.
Just those lights. We don't put them on.
Yeah, so I don't know what I'm gonna do because I needed that credit to take a class for.
Just go like run a mile every day and be like, that's my gym class.
Yeah, I think it works like that.
Go talk to Miss Holmes.
Go lightly walk a mile. Briskly walk a quarter mile.
That class is called Walk, John Abrams.
I thought you had weight training.
Are you ready,
I
Dale?
did,
Oh, you did.
but now.
I'm ready, yes. I'm just
Right.
kind of checking roll real quick while we're hanging out. Everybody's here.
It's hot.
I was like, it's so nice and
Fun
cool.
is,
I got up here, that's like,
This is amazing.
great.
okay. You alright?
Okay, so I guess, everyone have a good weekend?
Phenomenal.
Yeah.
Pardon me? I asked you, oh, yeah. Okay. So, what questions do you have? Well, with some of you did respond to the post I made about that problem with in class, and so with the extra credit for that. Good job. I think everyone got it correct. The fact was that the ratio that we had of leading coefficients was a 1, and so that gives a horizontal asymptote of 1. The horizontal asymptote of 1 is negative 1. So we had to multiply by a negative 1. I think everyone got that. So that's good. Okay, but section 4, you had your transcendental functions. Transcendental, they transcend the normal algebraic functions. So we will learn in Calc 2 how to represent these functions as an infinite sum of polynomial-like terms. So now, it's normal sine and e to the x1. Okay. So let's go over to problem 1 again, just to kind of get our bearings going for today. So 1A, volunteer to start us off on 1A. Volunteers. Joe's going to volunteer. Fantastic. Thanks, Joe.
Function f of x equals 3e with 0.5x minus 2 is an exponential function. True.
Actually, that's false. It sort of looks like it. The only thing is, the only contingency, I would say it looks a lot like it, but the definition of a exponential function does not include addition or subtraction terms. So it's technically a transformation of an exponential function. It doesn't, a little tricky. They were just being real picky there that's is the science. That to me is almost a little too picky, but yeah, by actual definition, it only has the exponential term, not the -2 term. Transformation. But how would the graph be transformed? While we're talking transformations, how would the graph of that function, 1a, be the transformation of a standard exponential function? To describe all, not just Joe, anybody, describe all of the transformations involved in that function. You have transformation ideas, Davidson? On 1a? Let's be specific. How about the 3 that you see in that function? What is it going to do in transforming the picture of that function? Which direction? Yes, it's going to stretch it vertically. That's correct. By a factor of 3. What about the 0.5 that you see in the function? What is it going to do as a transformation? Emily, do you know?
Me? I do not know.
Who else might know what the 0.5 in the e to the 0.5x, what is that going to do to the transformation of your basic e to the x function? Okay. Horizontal's correct. It's actually, but when you're pre-adjusting your x values, it's actually goes the opposite, so it's going to actually stretch it by twice as wide. So yes, you're on the right track. Good. And finally, the -2. What is it going to do? I heard someone's. Is that you, Bree?
Yeah.
What did you say?
So it's going to move it down.
Yes, good. Okay. How about problem 1b? Volunteer? Okay, Mason. This is good. Mason.
Okay, 1b, true or false? Every exponential function f of x equals ac to the kx.
C?
Ae to the kx has a horizontal asymptote at y equals 0. And I put true, it has to have a plus or minus value at the end to change the horizontal asymptote.
Correct. Yes. I agree with you. Good. How about one, which by the way, so then what is the horizontal asymptote of 1a based on what you just said?
Would be at -2.
Way too low.
Okay, good. How about 1c? Volunteer to take 1c? Andy, you want to take 1c for us? Please?
I can do it. I'll do it.
Oh, okay, very good. Take it.
Okay, 1c. True or false? For all x is greater than 0, the natural log of x cubed is equal to 3 natural log x. That's what we're talking about, right?
Yes, that's correct.
Okay, and I put that it's true because earlier in the chapter when it talks about logarithms, it sets like a bunch of rules. And
right.
It's on page 49 and it just matches with this one rule letter D that they have there.
Great. Absolutely correct. Okay, problem 1D. Here. We'll let Sammy go on this one since Fred's the volunteer class.
True or false? For all x greater than 0, the log base 2 of x over the log base 2 of 3 equals the log base 6 of x over the log base 6 of 3. And I put that it's true because of the base conversion formula that's mentioned in this section.
Absolutely correct, yes. That is the change of base formula, base conversion formula. Good. 1E. Jacob, want to take that one first?
True or false? If x, when x, y is the point on the unit circle corresponding to the angle -7 positive 3, x is positive 5. So that's true because of the quadrant location, 7 positive 3.
Yeah, I agree. So negative 7 pi over 3. Let's see. That's how it works. Start at 0. Which way is negative on unit circle? Clockwise. So if I go all the way around, that's 2 pi, which is 6 pi over 3. So 1/3 pi more is going to put me in the fourth quadrant. So I'm going to agree. X, Y is the Y. Okay, good. How about 1F? Kyle, would you volunteer?
The sine of an angle of theta is always equal to the sine of the reference angle for theta. And I put false, or yeah, false. Because if I'm not mistaken, your reference angle is always in the first quadrant, correct?
Correct. The reference angle is always an acute angle between 0 and 90 degrees. And so it will always have a positive sine value, but any angle could have either positive or negative sine values. They will be otherwise the same, but could be plus minus. So I agree with you, yes. How about 1G? Want to volunteer? Kyle, do you have a question?
No, I was going to do that one too, but maybe not.
Going to volunteer. Okay, volunteer. Let's go ahead.
Well, do you want to do it, please?
No.
Bree, you raised your hand quick, Bree.
Alright. True or false? For any x, 1 minus cosine squared of 5x to the third equals sine squared of 5x to the third. And I said true because 1 minus cosine squared is equal to sine squared.
Yeah, that's, which identity is that? Can you name the identity?
The
Pythagorean.
Yeah.
Okay, good. That's good. True. How about the last one? Hey, volunteer? Hey, Justin, volunteer.
True or false? Secant negative 1x equals 1 over x.
Be careful. Read that formula as inverse. Secant inverse.
Secant inverse. Negative 1 over cosine inverse. So that's
yes, secant is 1 over cosine, but secant inverse is not equal to 1 over cosine. It seems like it ought to be, but it's not. Just for clarification, I'm going to go start with you. So I agree that secant of x is equal to 1 over cosine of x. If you look at the, we'll pause here. Y'all see that now on the board?
Yeah.
Okay. So secant of x is equal to 1 over cosine of x. If you look at the definitions, it's easy to identify this property. But how do I handle understanding inverse secant related to inverse cosine? Well, what I'm going to do is I'm going to call this answer, say y. And then I'm going to apply a secant to both sides of the equation. On the left side, when you take the secant of the inverse secant of x, what do you get? Or somebody say it. Joe said What was it? X. Just x, that's right. Let's see. So we're trying to figure out what y. So x equals secant of y, so therefore x equals 1 over cosine of y. I'm trying to understand how it relates to cosine inverse. So I'm going to do another step here. If I cross multiply, I get x times cosine of y equals 1. If I divide by the x, I get cosine of y equals 1 over x. If I take the inverse cosine of both sides, the inverse cosine of the cosine y makes y. And so I have, and the key is that this y, that y are the same y, so therefore inverse secant of x is equal to inverse cosine of 1 over. So there is a reciprocal point of view to it, but it's not 1 over inverse cosine. Go back to state this, folks. How many realized that that was the relationship? Inverse cosine, inverse secant is inverse cosine of 1 over x. So if your calculator doesn't have an inverse secant button on it, and most of them do not, to calculate inverse secant, you do inverse cosine of 1 over x. Y'all familiar with that now? How many have seen that? Learn something new today. This is good. We covered new territory. Okay. What else? After that, what else? Other questions do you have? Notice says number 27. I think there was a post about that. So follow that? Okay, so we're trying to find the domain. ln of x plus 1. And Rachel, you had a post about that. Did you figure it out after that post?
Oh yeah, I actually figured it out like a couple of minutes after I made the post, and I felt pretty stupid afterwards.
Well, it's okay. You know, next time, after you figure it out, you can go back and repost and say, I figured it out, this is how you do it. And that would help everyone else as well.
It was such a small thing I was forgetting too. So it was like a big revelation. Right. Found it out.
Each of the 0 part? Each of the 0?
No, it's like the domain's like 2 and
ln of x plus 1, ln of x plus 1.
What? 1? So it can't be 2.
What number is it?
27.
This is number 27 that was asked. We posted about that last night, or yesterday sometime. The top has to be go through as well. So, yes, there's 2 aspects to this. Aspect 1, the domain of each individual logarithm has to be positive. So if I look at each one of these, I have to have x plus 1 is greater than 0, and I also have to have x minus 2 greater than 0. That means x has to be greater than negative 1, and x has to be greater than 2. Right. So which of those? I mean, do I say both of those, or how do I interpret that information? So I take the intersection of these two sets. What's the intersection between these two? This set numbers, that's the set. What's the intersection? Well, picture. Okay, so here's -1, and I'm saying take everything there. And on the similar graph, in comparison, there's 2, and I'm saying take everything there. So what's the intersection between those two? 2 up, right? So what I've got out of all this is I have to have from 2 to infinity is just handling these 2 logarithms, but that's not everything that goes into the domain of a function. So that's just to make the logarithms work. As long as I'm bigger than 2, then both of these will work. The other part of the puzzle is, as you know, when you deal with rational functions, the denominator cannot be 0. So I want the natural log of x minus 2 to not equal 0. So a couple ways to handle that. And when is this logarithm equal to 0? Well, you can handle by yes, because logarithm of 1 is equal to 0. Any log. So we want this to not be 1. But if you don't remember that, you can always just solve. Always just solve it.
I wanted to die. I didn't sleep till 1 o'clock yesterday.
Gave me I think they cleaned the boards and they put gunk on them. And they already sleep. Oh my God. Well, hey, paper towels. Like a dang engineer, got to solve the problem. Just make it right. That helped a little bit, but not a whole much. Okay, so if you don't remember that property right there, you can always just solve this equation. You would raise each side to e, and since logarithm and exponential are inverses, if I raise e to the logarithm of x minus 2, this cancels and you just get x minus 2, and e to the 0 is 1, which is kind of what we're saying over here. And so then we want x not equal to 3. So if you put that information with this information, your final answer should be what?
2 to the 3 union 3 to infinity.
Good.
Wait. Got him.
I have a clean eraser that actually. I have one moment, I'll be right back. Let's try to cross the hole. Thank you.
That's great.
Because the ln of x is 0 at 1. Because the ln of 1 equals 0. So you could like say e to the 0, like he has it there. I mean, I would just change the base and say e to the 0 can't equal x minus 2.
He said they all left us.
So the other end was cleaner.
Yeah, that does something. I'll have to ask. We may have to fall back to the tablet here.
Or we can use either to work on the front, on the sides.
Yeah, I mean, that's gonna I think that's the same. Honestly, I think that's the same. They put, it's got some kind of something on there. That's like, okay, so what else? While I'm kind of ready.
Is he asking for a different question? Yeah. Okay, I have a question.
Yes.
Be there.
Try to
Okay.
figure out. Start with that.
What is he saying?
He's trying. Saving.
Oh wait.
Go ahead. What's your question on
It was number 57.
number 57? Number 57. Something like that. That's a song. Number 57.
Get smart.
Get smart.
So that was 99.
We got going on.
Takes a couple seconds.
I can always right here until that comes on. 57. Sine of the inverse cosine of x. That's what I want. So I'm going to try to write right here. Okay, so this is number 57. So the sine of the inverse cosine
I
of
can actually
x.
see it. This is great.
Can you read that?
Yeah.
Okay.
Can you see it?
Yeah. I can read.
Okay. So what we're going to do is we're going to call this value right here an inverse cosine, or inverse trig is undoing trig. So trig takes, like cosine takes gives you a value for a given angle, gives you an output. So opposite or inverse is giving you an angle. So we're going to call that angle, say theta. And then I'm going to draw a triangle. This is going to be angle theta. So what does that mean? It says based on what that statement says, I know that the cosine of theta has to equal x. That's what the statement says up there.
Where'd you get that?
So this inverse cosine is giving me theta such that the cosine of theta is x. So now I can label that information on my graph. Cosine is what? From right triangle trigonometry. How do you calculate cosine? So I have to have adjacent over hypotenuse. And then, what does that mean about the opposite side? Pythagorean theorem tells me this is the square root of 1 minus x squared.
Where did the 1 come from?
Where did 1 come from? That's a good question. 1 came from x is the same as x over 1.
Where did the 1 come from? Everyone's talking to me at the same time.
Sorry?
Where did the 1 come from?
I just thought of the number x as being a ratio of x over 1 so that I have a numerator, which is my adjacent, and a denominator, which is my hypotenuse.
Okay, it's pretty convenient. I'll just accept it. Keep on going.
Well, you agree that any number can be written as that number over 1, correct? So there's always this kind of hidden inferred division by 1, or multiplication by 1, if you like. It's always there, just don't write it. It's inferred.
So I can put any number into this triangle?
Any number can be as a 1.
Yeah. Okay.
So x can be divided by 1 and still get x.
Okay. I'll just take it.
I mean, the whole point, the reason I did that was so that I've got the definition of cosine is adjacent over hypotenuse. I wanted a ratio. That's how you define your trig functions. And knowing that I wanted a ratio, and knowing that any value can be divided by 1, I just chose 1 as my divisor, and now I've got a ratio. I mean, I could have put 2x over 2, or 17.1x over 17.1. I still get x. Doesn't really matter. But I'm just one.
What?
Or what?
Isn't the hypotenuse supposed to be the longest side?
Yes.
So how's
What does that tell you about that?
Because we don't know what x is. X can be less than 1.
Well, you said if it's any number, it could be something bigger than 1. And then that wouldn't make it a hypotenuse anymore. You're like, I don't know, you're undermining the triangle. It doesn't make sense to me.
I didn't say x could be any number. I said any number divided by 1 is still that number. Since my triangle, 1 is the hypotenuse, then I automatically restricted my x to be less than 1.
Why are you even using the triangle?
Well, I'll get it later. I'll just take notes on it now. I'll get it later.
Well, let's keep going and see, and then we can do another one. Okay, so that tells me I've represented inverse cosine of x as an angle theta. So that's what inverse cosine gives you, an angle theta. So because of the fact that it's telling me that the cosine of, again, you have to realize that this statement, I don't like there. This statement here, inverse cosine, by definition, is giving you an angle theta, such that the cosine of theta is x. That's what the statement says. That's the definition of inverse. Inverse cosine of x means an angle theta so that the cosine of theta is x. But I also know that cosine of theta is adjacent over hypotenuse. So I just decided to rewrite my value x, which comes straight from the definition. I rewrote my value x as a fraction to meet this other definitions, like 2 definitions of one on in there. And once I have that, I'm ready to go, because now I'm calculating the sine of angle theta. So looking at my original problem, I have sine of parentheses right here. This is my angle theta. I've got a picture over to the right that has angle theta, and I need to find the sine of that angle theta. So what is the sine of that angle theta that you see in the picture? Top my hypotenuse is the square root of 1 minus x squared over 1, which simplifies to the square root of 1 minus x squared.
I can dig it. Yeah, I can dig it.
Dig it now?
Sure, I can dig it.
Okay. Well, if we can dig it, let's dig one more.
What do you say?
He said, well, if you can dig it, we'll move on.
Okay. I just don't dig the arbitrary assignment of values. Okay.
Well, you're right, but it's still arbitrary. The whole thing is still arbitrary.
Yeah,
All in terms of x. What's the tangent of the inverse sine of Well, let's do something a little crazy. Like x plus 2. Uh-oh, I was blowing everything out.
This man's trying to kill me.
I've got an arbitrary x, and we got a fixed number 2 involved. By the way, in terms of transformations, inverse sine of x plus 2, how is that inverse sine of x plus 2, how is that transformed from the basic inverse sine of x?
Does it move to the left?
Yeah, that's good. So I've just got a different graph on my mind. I've just shifted everything to your left. All right. Okay. So I want to figure out what the tangent of that angle is. One more time. When we talk inverse trig. Uh-oh.
Wait it on.
Okay. Inverse sine is a trig function that gives me an angle theta. That angle theta, by definition, where sine of theta equals x plus 2. That's what the definition of inverse sine is. So I'm going to go over here to the right. I'm going to draw myself a little right triangle. I call that angle theta. So if the sine of theta is x plus 2, there's only one way I can label the sides of this right triangle. Only one. Involving x. 2. What is that? Think of it as x plus 2. Or 1 if you like. Because I like to have ratios when I'm dealing with right triangles. If I'm dealing with unit circle, this is another definition of sine. I don't need ratios. When I'm dealing with right triangles, a ratio is. So what would it look like now? Opposite side would be x plus 2. Hypotenuse being 1 this time. This is going to be the square root of 1 minus x plus 2 squared.
Okay.
So what's the answer to this one?
Tangent is sine over cosine.
Yes. Or opposite over adjacent by definition.
Yeah.
X plus 2 over the square root of 1 minus x plus 2 squared. You're getting a little more comfortable with it now?
Yeah. But that's only because I was given a value this time, and I don't know.
Given a value? Still have an x in there. About the tangent of inverse secant of 3x. I'm going to stop talking for a minute. To breathe, not want to breathe itself. Look at me, the first one to get this one right.
Okay.
No, lock. Can't go anywhere. I got you. Yeah, I'm gonna talk to her. I'm glad she cleaned it, but I wish she was something different than what she did. See what happens. actually want to volunteer yet? No answers. Volunteer. Let's hear what. I'll write it down. Whatever you say here. Let's see if it's right. Volunteer to answer.
I got
Yes.
Yeah.
Else get that?
That's right.
Anybody else volunteering? Anybody else get a different answer? Abby, what do you get?
3.
So another answer right here is this. What's one? My eraser. One square is still one times. I have a different answer. That's two different answers. It's about the same. Ernie volunteers yet? Dave, step up. Get one out of the park.
Come on, Steven.
I can hit it out of the park if you don't take a swing. No one has any answer at all? You have. Liz, what do you have?
What did you say?
You have.
Okay.
What do you?
I have root of 1 minus 3x squared times 3x. I don't know. There might be 1 over 3x or something.
Times 3x like that? Is that kind of what you have?
Yeah, and also it was the other way around. It was 1 minus 3x squared.
Oh. Okay.
But I can tell by the way Miss Klinger's looking at me that I'm wrong, so I have her disapproving glare.
Well, you know, that's one of the foibles of being an instructor. You want the student to be right, so you can't help but go, "Oh, why would you say something dumb like that?" So
I'm part of the math club.
Let's try it out. Let's try it out. Okay, so it looks like I've got a secant inverse of 3x, which I'll kind of scroll past. So that's theta. That's theta. What's the definition of secant? That means secant of theta equals 3x. In right triangle trig, what is a ratio definition of secant of theta?
What is this? Yeah, I got that.
So that means this is 1, this is 3x. Root of x squared minus 1. We're looking for the tangent. So the tangent is square root of 3x squared minus 1 over 1, which simplifies the square root of 9x squared. That is starting in.
There you go. This is black.
You know, I'm not sure who the engineer is that decided that they should put quick buttons right where you put your hand on the screen, but they should be taken out back and be little bit because that's just kind of stupid.
Total
Mistake. I thought I was ever an engineer who got in trouble. That's just stupid. Okay, so the answer is square root of 9x squared minus 1. Did anybody get that?
I don't believe it.
It's got the earlier version of it.
You had quantity 3x squared minus 1? I would accept that. 1. Okay, well, we've beat that horse. What other questions you have?
I don't believe it. I don't buy it.
I'm sorry, Brittany. What's up?
Can you go over 63?
50. Sure. Go over 53.
63.
60. I apologize. Misunderstood.
63. Senor Gaddis.
That's just the same thing as that.
No.
Brittany. It's a little more complicated. Okay, so we got cosine 2 inverse sine of 5x. Now, the key here is to recognize that the inverse sine is your theta. So I'm seeing, when I look at this problem, the first thing I'm thinking of is cosine of...
Yo, that's a double angle identity.
Oh, yes, we have a winner. Ding, 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 ding. Okay, so yeah, we need a double angle identity. What's that double angle identity for cosine of 2 theta?
Well, aren't there two things you could do?
And you can be rewritten in half a dozen different ways, but there's one, what I consider primary one. You can use whatever one you want. Things like cosine squared of theta minus sine squared of theta.
Mm-hmm.
Comes from the angle sum identity. So remember that? That's our this. So I need to find. Apparently, I need to find the cosine of theta and the sine of theta for the given theta. Square both of those values and then subtract them. Well, that's not too bad. This particular theta, this theta, inverse sine, so this says that the sine of theta equals 5x. So 5x there, 1 there, square root of 1 minus 25x squared there. So this is the square minus square, or something. Square of cosine. Cosine is square root of 1 minus 25x squared. And the sine, well, we just said that's 5x, so I guess I'll just put 5x in. So this becomes 1 minus 25x squared minus.
Yo, hang on a second. Yo, that's black. That's not cool.
Where'd the 2 go?
That's not cool.
Any other questions y'all are struggling with?
That doesn't look like the answer. That's not how they do it.
2.
No. It is easier. But the book is saying otherwise.
Enjoy this.
He's at war with the book. Gale Davis.
Up all of that this time? Did that answer your question?
Yeah.
Can I ask a question?
Yes. Just want
Okay,
to?
so, it's like a follow-up to this. With
Okay.
these basic trigonometric identities, do we need to have all of them memorized for tomorrow?
Yes.
Okay. Just asking.
Good. What other questions?
I have a question.
I'm sorry, Kyle, question.
Can you do number 45?
All right, say it one more time. I didn't hear you. Is that 25?
45.
25 wasn't even a sum.
Mad.
25 or 45? I'm
45.
We didn't even have to do.
45.
Yeah.
45. And you have to understand that when y'all are talking, it's hard to hear. Plus, there's noise here like this. This unit, this behemoth I have to stand behind now is making a lot of noise because it's got computers and fans and stuff in it. So, project. Pretend you're in the boardroom trying to impress the CEO so that you can get a promotion from chief financial officer to vice president. Project. Okay. 4 5. The x equals 3 to the x minus 1. What? Solve the equations. 35. 2 to the x equals 3 to the x minus 1. I cross multiply. Would that be a suggestion I could do here?
Can you cross multiply? Doesn't look
What
like
would
a
you
ratio.
cross multiply? I was being facetious. What would you cross multiply?
What would you cross multiply?
Look. One method of solving this, I think, is I hear someone say, Jacob would say it aloud. Natural log. Supply the natural log to both sides. Okay, so what happens if I do that? I get the log of 2x equals the log of e to the x minus 1. Did I just say 2x or did I say 2 to it?
That's cheating.
So now how is that going to help me? Good suggestion, Jake. Why would I want to do that?
I don't know. The next thing I know, you pick the next one.
Yeah, you can apply one of the properties logarithms now. And the left-hand side of the equation becomes x times natural log of 2. And the right-hand side becomes x minus 1 times natural log of 3. Now that's, how do you solve that? Suggestion, Kyle? Did you have a suggestion, or were you just?
I was scratching my head.
Okay. Okay. Bless you. It is kind of a head scratcher, right? Bless you. Yes. The objective here is we need to. I see that the x's are now linear, so I just simply need to combine, quote, combine like terms. That means I've got to get individual terms. Right now, the right-hand side is factored, and I need to make terms out of it so I can combine like terms.
Oh, sweet.
So x natural log of 2 equals x natural log of 3 minus natural log of 3. Now I have terms, simple linear equation, combine like terms, etc. So this is x natural log of 2 minus x natural log of 3 equals negative natural log of 3. Oops. Then factor out your x.
No way.
Thank you. Well, they're the hot buttons. They're physical buttons.
I'll give you an answer.
You put your hand on the physical bugs right here. They're sticking up, and you can't help but hit them. Yes, I can. And I would probably rewrite that. It's fine the way it is, but you could actually factor out a minus sign top to bottom and get something like this. You can even go further if you wanted. Using properties, this would be the log of 3/2.
Yeah, I believe it.
So, if this were a test question, do we need to get that final answer if we stop at where you have x equals the negative ln, or natural log of 3 over the natural log of 2 minus the natural log of 3?
Yes, you want an A or a B?
Oh my
I mean, I would prefer an A. I don't think it's going to get there. I might have to settle for a B.
You better do this.
I would probably actually accept the first answer. The book would probably clean it up a little bit to the second answer. The third answer is even better, and back in the old days, we would clean it up even further. We call this log base 3/2 of 3. You get to the edge of the screen, and this work. Another good thing to do. And so I'll do that again. Log base 3/2 of 3. How can I do that? How can I write that last statement?
Why? Is that like the base conversion formula or something?
Yes.
It is?
Base conversion formula gives me
Oh my
that.
god.
Now
Okay.
you've got it in the simplest form you can write it in, which is actually quite nice. But I would accept the first answer. If you can solve for x, we'll call it good there.
Okay, I have a question about that process. That first answer, the one that Kyle asked about, how'd you get from that first answer to that second answer? Like where you
I
just
factored out a negative sign out of the numerator and denominator, cancel. So if I factor a minus sign out of this, that becomes a negative, that's a positive.
Okay.
And because I'm dividing top and bottom by a negative, I can do that. Brittany has, oh yeah, I saw it the same time you said it. Brittany has a question. Yes, Brittany.
When do you know when to use natural logs versus regular logs?
Try me one more time, Brittany.
When do you know when to use natural logs versus regular logs?
Well, I guess it depends on the situation. Technically, it doesn't matter because you can convert between bases with the conversion formula, but technically it doesn't matter. I typically use natural log almost exclusively unless I'm dealing with a base 10 problem. If I'm dealing with a base 10, then I'll use the common log. But otherwise, I use natural log almost exclusively. It technically doesn't matter. I don't know if that answered your question, but did that answer or not?
Yeah.
A lot of noise right here beside my head. You have to speak up so I can hear you.
Not answered.
Good, I guess. Other questions? Sammy. I wasn't here. Sammy.
Can you go over number 55?
55. Thank you. Yes, I heard that. Okay. Problem? Okay. 55. We are given, so these are my givens, cosine of theta equals 1/6 sine of theta is greater than 0. Sine of I or B is 3/5. The cosine of B is less than 0. That's the givens, and we are asked to find the SIGN of cosine. Well,
What's that second sign?
I would contend that we could actually find the value of cosine of theta plus phi. So I'm going to do that. Once I do that, I'll know the sign. Okay, so how do I do that?
PHI.
So
You know this, man.
the first thing we have to do is recognize that I have two separate angles here, and I know information about each one, but not both together. So I'll have to split this up, and I have a sum identity. Remember what the sum identity is for cosine? That's right. Cosine times cosine minus sine times sine. So now, all I'm looking for is only in terms of the cosine and sine of those. And even though it didn't ask the question, I'm going to go ahead and calculate the value, not just the SIGN. To do that, I need to know cosine of theta, and that says right there is 1/6. So this says 1/6. So right there, in place of cosine of theta, I'm going to put 1/6. And sine of theta and sine of phi is 3/5. So right there in place of sine of phi, I'm going to put 3/5. The only thing I need remaining is the cosine of phi and the sine of theta. So how am I going to find those two numbers out? Or draw a triangle. Yes, we'll do that. So my triangle for theta. Cosine of theta is 1/6. That puts 6 like that. This is what, square root of 35. And then we do a similar game for b. The sine of b is 3/5, so that's 3 and a 5, so that's got to be square root of 16, which is 4. Okay, so cosine of p then is 4/5, and it says cosine is less than 0, so it's negative 4/5. So that must mean we're in which quadrant? Okay, go back up here for a moment. These two pieces of information right there. What quadrant is angle phi in?
Well, if the cosine is less than 0, and the sine is in a positive area, is it going to be in quadrant 2?
Yes, good. Quadrant 2. do the same game for this one. What quadrant is this one in? Theta.
Did you see me again?
Let's see, quadrant 1. Let's follow the side. Okay. And now, the final piece, going back to the triangles, I still need a sine of theta. Sine is positive in theta, so sine is 35/6.
Yeah. I can believe it.
It's negative 4/30ths minus 35 30. Was that negative or positive? Is the answer negative or positive?
Negative.
That's negative. I don't even need a calculator for that. Okay. Any final questions? Hot in their room too, like
Yeah, they're all fans.
we're fans. Last questions.
I'm fine.
That's time. Okay. Question, Dick?
We can come in 15 minutes early tomorrow.
I'll come in 15 minutes early tomorrow. And Dave, so you said you're going to stay 15 minutes late tomorrow, is that right?
If Clinton wants us.
Yeah, I think so.
Yeah.
We're on time and in 15 minutes late. Okay, we'll see you tomorrow morning then.
Oh boy.
And you're gonna email me, Dale?
Yes, I will email you here shortly.
Okay.
What time's your next class?
10:15.
Are you going to just study hall right now, or are you going back to your home?
I'm gonna hang out. A couple students have asked me to hang out for a question or two.
Okay, fantastic.
Are you going to stay this time?
I can do that, sure.
I was looking at I'm not taking that. I think there's something right inside the video.
See you later.
I wanted that.
Are you good, Reza? Triangles are good?
They're okay.
Good.
I just can't stand the way everything's worded in this corner. I mean, like it's 2 times harder than it needs to be.
You mean in the book? Or
Yeah, it's a book.
Oh.
And but I was looking at my pre-cal notes last
Which will
night,
come in handy.
and I was like, thank God I had this.
Disclaimer, I think summer break's the most counterintuitive thing ever. Because I've forgotten like 75% of what I learned in pre-cal. I have to refresh everything now. It's like I'm relearning it.
Yeah.
Yeah, I think
In
like,
4 sections.
I think it's good for like elementary school kids for them to have a summer break.
I mean, I feel bad for you guys because you didn't go through 171, and so you're probably not as good with logarithms and
No,
exponents.
we're not.
I mean, I forgot all of it, so.
Yeah, me too. I'm gonna go home and review all of my pre-calc.
Yeah, I talked to Miles about this. I was like, probably you're gonna want to get them in 171 and not skip it.
Yeah.
Well, for everyone else, correct. Yeah, we can't even go back.
Right.
Yeah.
For this.
I mean,
I'm just glad that you had us take really good notes because I'm like studying our old notes.
yeah.
Like
Must
get on
be
all
nice.
those slides
Must be
and
nice.
stuff.
Yeah, those
Yeah.
slides were so
Yeah.
helpful.
I
Yeah.
don't mean crappy math or notebooks.
I just feel like I think that summer break's good for like elementary school kids. There comes a point where it's like training kids to hate school.
Yeah.
Right? And especially in high school when they want you to retain the information from last year. It's
Yeah.
just